Hello guys, another problem that deals with forces in 3D. And of course these are the first problems that are supposed to be easy and are supposed to be for you to learn how to find the components in 3D of any force given the magnitude. And that's exactly what we are giving here. We're giving the magnitude and these two angles. I'm sorry, giving these two weird angles here that we don't know what they are. But if you remember your theory, and you remember what happened, you have some angles that are called alpha, beta, and gamma, and those are also called the director angles or the cosine director angles. The reason for that is because those are the angles that are formed with the x, y, and z axis, respectively, and these will be the component of the unit vector in the x direction, in the j direction, and in the k direction. And if you have the unit vector, which is just this, basically this for the force, and you multiply that by the magnitude of the force, then you have the force in Cartesian notation. Now, how do you identify alpha, beta, and gamma? Well, alpha is the angle that the force makes with the x-axis, and it's not an angle that goes in the plane. It's an slanted angle always. It's from the angle to the force. It goes oblique like that. So that will be alpha, and with the y-axis that will be beta. These three cosine directors are not independent, and this is once again based on spherical coordinate system. Cosine square alpha plus cosine square beta plus cosine square gamma has to be 1. They are not independent from each other. Uh, we have alpha 50 and we have beta 60. 50, 60. So we need to solve for gamma. And cosine gamma should be the square root of 1 minus cosine square 50 minus cosine square 60. So let's do that. Do that. 1 minus cosine 50 square. When I deal with trigonometric functions, I don't mind putting an extra parenthesis because it's going to save me a lot of troubles, and that's why I always do that. Square. Square root of this, and then I have this. This will be the cosine of the angle. So cosine of beta, of gamma, should be 0.58. Now, if you keep this as is, and you get the inverse cosine, you should get the value that you're looking for, right? So cosine, inverse cosine of the answer, that would be 54.52 degrees. However, this is wrong. This answer is wrong, at least. Not quite. This answer is correct. This answer is wrong. So you have to pay really, really good attention, because if you know, I know if you know, I know you know, every time you take square root, the answer is going to be plus or minus. And if you look at the direction of the force is pointing downward. So the unit vector of that force in the z-axis should point downward, which means this value should be negative 0.58. So if you want to find the angle, you can find the angle, or you can keep it like cosine like that if you want to. But you know, my OCD is telling me calculate the angle, which is going to be basically the same thing. I have the angle from before. So the angle that I had from before was syntax error. That was the angle that I got from before, the cosine of the angle, but I'm going to put a negative sign in front of that. That will be the cosine of the angle. Now, if I get the inverse of the cosine of that value, negative 0.58, then you're going to get 125.48. And that's the correct director cosine in the y direction. You don't need to do it, but you need to definitely add the negative sign here. So what would be the force in Cartesian? The force in Cartesian will be 450 magnitude multiplied by cosine alpha, alpha 50 in the I direction, plus cosine beta, this angle, or you can put this value, which we already know, plus cosine gamma, and gamma is, I'm sorry, this is gamma k, plus cosine gamma beta, which is 60. 60. This is beta. I just moved this out of the place. I mean, I was so excited. This is I, this is J, this is J, and this is K. So the force will be 450 cosine 50. That will be 289.25 I. J, 450 cosine 60. That will be 225 minus, that's what I was excited because I wanted just to include that sign over there, 450 times negative 0.58, syntax error again, times minus 0.58, negative 261 in the k direction. And that will be the force in Cartesian notation. Important takes of the problem. Look always at the direction of the components of the force, because otherwise you will have a positive sign here. I am sure of that, because you were going to calculate just not plus minus, you were going to say just inverse cosine of all of these, and that will give you an angle that it wasn't the one that we were looking for before, for the problem, because it doesn't make sense. So just keep paying attention to that. Thank you for watching, and another problem is coming.